everyone. Today we are going to see Huffman coding in digital communication, how to solve the Huffman coding problem. And this is vanilla. So the problem statement goes here. The five source symbols of the alphabet of a discrete memoryless source and their probabilities are. So the five source symbols are S0 to S4 and their probabilities are given. So design a Huffman code for a given source. Determine the average code length, coding efficiency and redundancy. So before start doing the problem, you have to check whether the sum of the probability is 1. So 0.33 plus 0.17, 0.125, 0.125, the probability, the sum of the probability is 1. So we will start the problem here. Suppose if the probability is less than or greater than 1, we shouldn't start the problem. So here first the step 1 is to find the Huffman code. So in this one, arrange the probability in descending order. So here the probability has been arranged in descending order 0.33, 0.25, 0.17, 0.125 and 0.125. Here the source is also given respectively. Now we have to add the least two probability and have to get the other column. So the least two probability should be added. So 0.125 plus 0.125 is going to be 0.25 and the next column should be written with decreasing order. So here 0.25 is 0.125, 0.125 is 0.25. Already you have this 0.125 in the column. So this new probability will obtain the highest probability. So this is how. So again the least two probability should be added here, that is 0.25 and 0.17, and you form the new line. So here 0.25 plus 0.1217 is going to be 0.42. Again I have to repeat this one until I get only two probability. So this 0.33, 0.25 is 0.58. So now we'll start coding in the reverse manner. So we have to give the values here, right? So upper value will be 0 and lower value will be 1. The least probability that we have added, so that should be allocated as zeros and 1. So upper will be always 0, lower will be 1. So upper 0, lower 1. Upper 0, lower 1. And upper 0, lower 1. So we have to code in the reverse manner. So 0.42 value is going to be 1. And here the sum of these two probability have given a new probability for 0.58. That value should be, the code word of that should be prefixed. So for both. So 0, 0, 0, 1. And again this 0.33 is 0, 0 and this 0.25 is this one. So the value is going to be 0, 1. And now the addition of these two probability have given a new probability whose code word is 1. So that should be prefixed for both. Again this 0.33 is 0, 0 and this 0.25 is this one, because the sum of these two probabilities this 0.25. So this 0.25 is this one, the code word is going to be 1, 0 and here it is 0.17 is 1, 1 and here the sum of these two probability have given the new probability with the code word 0, 1. So prefix 0, 1, 0, 1. So now we have got the code word. So the probability, the source, the probability and the code word of each and every probability. For 0.33 is 0, 0, 0.25 is 1, 0, 0.17 is 1, 1, 0.125 is 0, 1, 0, 0.01 is 0.125 is 0.011. So each and every code word is a unique code word. The repetition of code word is not there. If the repetition of code word is there, then the problem is wrong. So the NK, that is the length of your each and every code. So 2, 2, 2, 3, 3. So this is your step 1. So step 1 is to obtain the code word Huffman code. So next is step 2. So this part of the problem is over. So next is to find the average code length, code efficiency and then redundancy. So average code length, how to find this? The formula here is going to be summation k equal to 1 to k pk nk. So probability into the code length. So probability into the code length is 0.33 into 2, 0.25 into 2, 0.17 into 2, 0.125 into 3, 0.125 into 3 will give you the average code length. So the average code length is 2.23 bits per symbol. So the next is to code efficiency. Efficiency formula is entropy divided by average length. So this average length value we have already found out. So that is 2.23. We have to find the entropy. The formula for the entropy is summation k equal to 1 to k pk log base 2 of 1 by pk. So all the 5 probability should be written, and then you know it very well. While you are using your calculator, will be able to get your log base 10. So if you want to get the log base 2 value, so how to get this one? Log base 10 of a divided by log base 10 of 2 will give you the log base 2 of a. So type the value as such. Whatever I'm saying, you just type it in the calculator, you will get your answers correctly. That is 0.33 into log 0.33 inverse plus 0.25 into log 0.25 inverse plus 0.17 into log 0.17 inverse plus 0.125 into log 0.125 inverse plus 0.125 into log 0.125 inverse equal to. You'll get a value. Divide that by log 2. So you'll get your entropy as 2.2 bits per symbol. So code efficiency is 2.2 entropy divided by the average length 2.23, that is 0.98, that is your 98 percentage. So this is the code efficiency. The redundancy is going to be 1 minus efficiency. So the redundancy 1 minus 0.98 is going to be 0.02. So this is the redundancy. Thank you guys. Have a nice day. Subscribe my channel for automatic updates.